Okay, still busy with the reduction formulas? Whenever I say simplify in trigonometry, it means there's a lot of rules to take into consideration. So you start from the start. So 315, what's wrong with it? It's obtuse. Well, it's reflex actually, but we've got to get it to an acute angle. So my magic word that I use is, okay, so before poof. 360 minus, that's what I want to see. So I can take 350 and make it 10, 360 minus 45. Now guys, like I said to you previously, I want you to very quickly get into the habit of already immediately then telling me that it's 10:45. Because you know it's going to go poof. But then you've also got to take into consideration that you're in the fourth where 10 is negative. So if you can immediately say minus 10:45, that would be your first mark for that specific step. So whether you show it or not, it's just helping me at this stage, I think, to show it. Then 1020. Take away as many revolutions as you can, and where do you end up? 300.
360 minus 60.
300, so it's going to be cos 360 minus 60, which is going to then be cos 60. Okay, so let's go through the motions. First, we take away as many revolutions as we possibly can. Then we're going to decide it's the fourth quadrant. That's why we use 360 minus. Is that still 300? Yes. And then we're going to the poof and the puff signs. So let's get there now. For the sin 150, it's going to be 180 minus 30. This is a negative angle. So we make the negative angle a positive angle, but the ratio becomes negative, which will make this then a negative. Say, for instance, that was a negative, then it would now be a positive because you have to imply. Negative angle becomes positive, ratio becomes negative, and then you time with whatever's in front of it, which still has to be reduced. So it's a lot of extra work. If you can get yourself into the habit of doing it more quicker than that, it will be good for you. So we have shift, poof, and it's 10:45. Fourth quadrant, tan is negative. That's my first mark. Usually for the negative angles and the larger than 360, they combine the mark for doing both of them. Throwing away the 360 plus, the more than 360, and for throwing away the negative, and then for reducing. They normally don't give you 2 marks for going for 300 and then for going for the reduction. They don't normally give you 2 marks. It's only 1. Okay? Because you can see how many things are happening here. You can make this thing come 12 marks. And then for 10, so this one's going to become 730 because we go poof, right? 730, but it's in the second quadrant where sin is positive. If you want to write positive, I'm happy. Okay, and then 135 is going to become 10. 180 minus 45, I'm just saving myself some space here on the board. So that's going to then become poof. 10:45, right? But in the second quadrant, tan is negative. It already has a negative, so now it will become a positive. And I make it a large big fat plus there to help myself remember why. So reduction formula made it a minus tan, and then a minus times a minus is a plus. So I still have to go and do the cos 300. And to save some more time, I'm going to say 300 then will be 360 minus 60, making it cos 60. Okay, let's do this one. So it goes poof, cos 60. I'm in the fourth quadrant where cos is positive, but there was a negative, so it'll just stay up negative. So I'm just saving some space here. But rather write all of those steps if it makes you safer. Then what? Can I now do multiplication or whatever? It's not multiplication. It was adding and subtracting. So you cannot say, I've got a minus and a minus and a plus and a... I've got to actually go work out these answers. And it says no calculator. So I should be prepared to use special angles, which you are going to use your calculator for. You know if you have to know it or not. What is tan 45? 1 with the minus there. What is cos 60? A half. What is sin 30? And what is tan 45? All of that will be 1 mark for all the special angles, because we know you use your calculator, but it will be 1 mark. It won't be 4 of them. And then I only need the answer, please, which is? Alright, so each and every one of those reduction formulas are worth a mark. Reducing negative angles, reducing larger than 360. There were no co-functions in here, right? So it can be, it doesn't have to be. That's why we need to know all of the stuff, and then we can start simplifying and mixing it up together. Next one, 570, what do we do? Minus 360 gives me? 280. 210. Right? And cos 240, what do we do with that? 180 plus?
60.
And turn? 180 minus 45. And I'm excited when I see the 45 and the 60 coming out there, so that I know it's special angles. Now, unfortunately, I have to do 2 steps here. So I've got the 570 reduced to something less than 360. Then you still have to go and say 180 plus 30, which is going to go poof, and you're going to be left with 30. Negative. Because in all of that reduction and poofing and puffing, you've got to look at your sign. So we've got poof gone is the 180 plus, so it's 30, and sin stays. But in the third quadrant, sin is negative. Then you get your mark. For the next one, we also go poof. So you got cos 60, but you're in the third quadrant where cos is negative. Together with this plus, we'll make it a negative. If you want to first say plus and in brackets the minus and then later on say minus, it's fine. More steps. Here again you go. Poof, 45, 10. You are in the second quadrant where tan is negative. Together with that negative will make me a positive. Right, and then what? Use your calculator, although you're not supposed to, because these are all special angles, and they will give me minus a half, giving me, say again,
0.
Right, how many marks did this sum? Not as many. There weren't that many reduction formulas. You get 1 for each reduction formula, 1 for all the special angles, and the answer. So 5 marks. But in general, they're about 5, 6, maybe even 7 marks for these reduction formulas. This was your last homework sum. So reduce to an acute angle by saying 180 minus. That will become tan 60. Do you agree with me?
Yes.
But negative. And I'm very happy if you can do that directly. For now, if you still want to write 180 minus 60, then say, poof, what is the 60? Tan in the second is negative. I'm very happy with you. And we put the brackets because it is multiplication. Cos 210 will become 180 plus 30. So it's going to become cos 30. But I'm in this third quadrant, which is going to be negative, which is still multiplied, so I still have to put it in brackets. For now, it's good if you still write cos 180 plus 30. Not worth a mark, but worth maybe you knowing what to do. Then minus, this sin is going to be 360 minus 45, right? Which is also going to go poof, right? And then just be sin 45. Well, what about that square now? They just stay square, and the sign doesn't matter because it's square. whenever you square anything, you don't even have to check it out. Because sin actually in the fourth quadrant is negative, but when you square it, it's going to be positive again. But there was a negative in the front, so it's still going to stay negative. So it's tricky. You see this? Actually, you should have said it's minus sin squared. That's actually correct. If you've got the sin ratio, it would have been negative, but then when you square it, it's going to be positive again, and times with the negative will stay up negative. Are you with me? So the rule actually is if whenever you do have a square, you don't even have to check the sign. So we just have to say, poof, gone, sin square, 45. What does it mean? So it's sin 45 times sin 45. And it's positive, and that answer there is still a negative. Now we're not timing. This is subtraction and adding. Again, we've got a lot of what? Special angles. So larger than 360, there was none. Negative angles, there were none. There were only these basically reduction formulas. And now there are special angles. Tan 60 is what? Root 3 over 3? Over 1, sorry. Do I have to have it over 1? No. And then cos 30? Okay, with a negative. If you had wanted to already multiply here and got the plus already, it's fine. But this is subtraction, and then minus the sin squared. Now remember, sin 45 is root 2 over 2, and that's what you've got to go square. And now again, guys, next step, just the answer. Fine? Because I'm not testing whether you can work with fractions and square them and add them and subtract them. I'm testing whether you can do reduction formulas. So if from there you just give me the answer, I'm happy. But remember, you've got to be able to do it yourself if you need to. And what's the answer going to be? One. Okay, please. Okay, so if you just write your answer as 1, happiness. Calculator, but you've got to know how you work with your calculator. Inside of the sums, something else can now appear, and this is the sixth thing. If I talk about 6 things, what am I talking about? The first one was just the basic reduction formulas. 180 minus, 180 plus, 360 minus. Then you got your, and it doesn't have to be in a specific order, okay? Then you got your larger than 360s, you know what to do. Your negative angles, you know what to do. Special angles, you know what to do. Co-functions we haven't seen now today yet. And then the last one is the identities. Now identities only work in trig. The type of stuff that happens in the trig is because of the trig ratios that do intertwine a little bit. That's something weird and wonderful can happen, like tan being equal to the sin ratio divided by the cos ratio. We can have a look at that later. But that is a fact. That if you take the sin ratio in a triangle, the sin ratio and the cos ratio, and you divide them, ratio over ratio, and you divide them and get the answer, it'll be exactly what the tan ratio is. So in a sum, and we're going to see it happening, in a sum, when you've got sin over cos, you can substitute it with tan. If you've got tan, you can substitute it with sin over cos. And when are you going to do it? It depends on the sum. That's what makes the magic in trig. Everything is always different. There's not one specific sum that's always going to look this specific way. So we've got a relationship that we can use. And usually I'm going to teach you to go back to sin and cos. Even in the co-functions, I said to you that you only have sin going to cos and cos going to sin with the co-functions. What about tan? Tan can be written as sin and cos, and then we can go from there. Are you with me? You don't need to work with tan. You can make tan sin and cos. The other rule is that sin squared plus cos squared is equal to 1. It's a rule. Now guys, let me quickly show you why that is, and notice, well, maybe they'll ask you somewhere funky. If you are in a sketch and you have an angle, let's call it theta there, and we are looking at sin, cos and tan, then this would be my y value, my x value, my r value. Do you agree with me? Let's check it out. if we say 10, 10 then will be y over x. Do you agree? That means that sin over cos must also be y over x. Let's check it out. Sin over cos. What is sin? Opposite of hypotenuse, y over r. Do you agree? What is cos? X over r. Do we ever leave stuff this way? No, we change it into multiplication of the inverse. So you got y over r times r over x. What have you got? So it's not something that we just decided it must be. It is. That sin over cos, whenever you work it out, it works out to tan of the same thing. So the tan is equal to sin over cos, and cos is equal to sin over tan is equal to sin over cos. What about cot? You still remember cot? We're never going to work with cot. But by the way, what was cot? It's the opposite of that, and that would mean it's 1 over tan. So whenever you've got cos over sin, it would be 1 over tan as well. So we're going to be fixing it up a bit. What about the other rule? So that's actually how you prove that rule. How do we prove the other rule? That sin squared plus cos squared is equal to 1. Same thing. Let's do sin squared. And let's do cos squared and see if it's equal to 1, which I said. So sin, again, is y over r, do you agree? That's squared. And cos, right, cos, agree? Now if you want to simplify that, that'll be y squared over r squared plus x squared over r squared, which means everything over r squared will be y squared plus x squared. But what is y squared plus x squared? X squared plus y squared will be y. Pythagoras. X squared plus y squared will be r squared because of Pythagoras. And so what's the answer?
1.
You're never going to prove it, but there's the proof. Okay, so from now on you must know that whenever but does it work for sin and cos?
No.
It has to be squared. So we call them the square identity. Nobody's going to ask you that. And we call this the quotient identity. And still remember your math language from primary school. What is a quotient? Not a coefficient. The quotient is when you divide stuff. Your answer for a division is a quotient. Nobody's going to ask you that. Those are your two identities. Okay, now let's go back to the sum, because we're back to where we were. What do we do with 2 to 5? 180 plus. I'm happy. So we've got 10, 45. Plus or minus? Okay, if it's getting too difficult, 180 plus 45, we go. Poof, 45, 10 in the third is? Plus. Put the plus there to help yourself. This is a plus. So we're not multiplying now again, right? Then we got, ooh, here's not numbers, here's variables. What do? We go? Poof. Poof. So it's going to come cos theta. So the whole 180 minus is gone. Where does 180 minus belong? Second quadrant causes? Negative. There was a plus, so this has to be a? Negative. Times? No, it's 80. Then this is times, right? And this is a poof puff sum. And if you don't identify it, you're going to do it wrong. So let's do the poof puff. What's going to happen? Theta is the poof because 90 plus gone. Sin becomes cos. Where am I? Second quadrant, where sin is positive, not the one that it reduced to. The original one, sin, was positive. And please don't write it that way because now you're going to start adding. And you should have multiplied. Quickly, let me finish these. Negative angle becomes a positive. And the ratio becomes negative. Tan 45 is 1. If I multiply this, what's going to become of it? Agree with me? It's multiplication, so it's cos squared. At the bottom we have minus sin. I can't do anything to that. So here's the point I was going to make. Unless you knew these reasons, you don't know that 1 minus cos squared can be substituted with what? Look at this. 1 minus cos squared will be equal to sin squared. So an equation can be shuffled, right? So 1 minus cos squared is sin squared, which you're going to get a mark for knowing that ratio. And this still stayed minus sin, so what's my answer? Plus divided by minus is a minus? Just sin. Because sin squared divided by sin is just sin. Okay, I'll send you the homework on WhatsApp.
My friend,